Hello. This class is an introduction to the professional engineer PE exam. I also taped another separate class for introduction to the FE exam, the fundamental of engineering. But this one is for the PE, which is the second day of the examination to become a professional engineer. So with that, let's start. Why do we want to become a professional engineer? It certainly will help you get a promotion. If you want to open your own consulting firm in the future, you will be able to do that without the need of going to somebody else who's a PE and become your partner and so on. It is very prestigious. It shows that you have commitment to the engineering profession. You are not just taking your first degree in engineering and your second or third degree in something else. If you have a PE, also it will allow you to be responsible for your own work rather than somebody else. You prepare it and you give it to somebody else to supervise it, review it, and approve it. In the past, I could share with you that a PE was not that important, but not that important. It was an option. I characterize it by saying it was an option. If you have a PE, that's good, but if you don't, that's okay. That frame of mind, that mentality has changed, and I have seen it change in the past. I would say more than 10 years, 10 to 15 years. That if you don't have a PE, that means there's something wrong. It's either your schooling is not adequate, or you're not you don't have the devotion, and you don't have the time, and you don't have the capability to be a PE. If you become a PE, certainly your company will have more capability to obtain projects, and of course promotion will come with more salary, higher salary for you. What are the steps to become professional engineer? The first one is you take and you pass the FE exam. That's the first. You graduate from accreditation board for engineering and technology a school that's accredited by this board. Then you pass the second day, which is the 8 hours professional practice exam. After that, you have 4 years of engineering experience, and then you apply to the board, to the licensing board, and they give you your PE license. The PE format, it's 4 hours in the morning. That's 40 questions. Each question weighs 1 point. And then 4 hours in the afternoon, and again each question weighs 1 point. That's 40 questions, 40 points. So the total, you can see, it's 80 questions. There are different disciplines, so I'm giving the examples. I am a civil structural engineer, so I'm giving this example from the civil discipline. So for the civil discipline, there are 5 disciplines, and same thing for other disciplines. And you have to go to nces.org to obtain a list of those disciplines. So in the morning, you will be asked questions from all of those 5 disciplines. 5, not 4, sorry. 5 disciplines. If I have said 4, there are 5 disciplines. So in the morning, you will be asked from all of those 5 disciplines. However, in the afternoon, you have to select one of those disciplines, and all of those 40 questions will come from the discipline that you selected. And that's applicable to all of the fields: electrical, mechanical, civil, and so on. The PE exam is offered twice a year, except if you are one of those fields. It's not offered. Some of them offered in April, some of them offered only in October. In 2010, that wouldn't affect you that much. Whatever discipline you selected in the afternoon, you will be given the questions only from that discipline, while in the past they used to give you all of the questions. This is a sample specifications for civil. So if you are a civil engineer, and here are the topics: 20% from construction, 20% from transportation, and so on. So go to this nces.org website to get the complete list of all those disciplines and what topic they will ask you. If you are taking the afternoon, you are civil, and you're taking the afternoon structural, also ncs.org gives you a list of 12.5% from this, 12.5% from that. So go to ncs.org, it will give you a very good idea what type of questions, what type of topics you need to study. Now I want to go over the concept of most nearly. So what's the concept of most nearly? It's often that in the exam, especially for the PE exam, they will ask you, they will not say a definitive question, they will say what is XYZ most nearly, or the answer most nearly is. Well, most nearly is meaning you will solve something and you will not get the exact answer in the choices they give you, A, B, C, and D. So generally, if the problem they are giving you is an analysis problem, it's a problem that you are asked to analyze something, then you need to select an answer from the choices that is given, the closest answer to what you found. Okay, so that's analysis. However, if it's a design problem, then you need to go ahead, take a step back and use your judgment. What are you designing? Is the answer should be lower than what you calculated? The closest to, but should be lower, or should you go to the one that is closest to your answer but slightly higher? And that make a big difference. So we will go to an example just to illustrate those two very, very important points. So here is a question. It says, what is most nearly the reaction at P? So the reaction at P is unknown. We set up this, we calculate. We will not do this one. I do this in static class, but here you calculate your reaction at P and you obtain 2.66 kilonewton. Okay, so now we go to the choices. It is not 1.5, it is not 2.3, it's either C or D. So what do? Should we go higher? Because sometimes higher is better. You're telling them that, oh, even though I calculated this, but I'm going to go bigger because that is good. That's conservative. Not necessarily. Not necessarily at all. In this problem, it's an analysis problem. You don't know what the engineer will use this reaction for. You have no idea. So you go to the closest. The closest to your answer, 2.66, is C, which is 2.6. So you don't just blindly go to the higher one. So the answer is C, not D. Here is another problem where you are asked to calculate the deflection of this beam. So how is the deflection? Is this beam is going to deflect, you know, this way, right? That's the deflection of this beam. So what they are asking you to calculate is the beam shape is this. They are asking you to calculate this vertical deflection. So we calculate the deflection. It came to 2.1, right? So that's 2.1. Okay. Let me just say, okay. Let's erase this. Alright. Okay. So you calculated it's 2.1. Now we go to the choices. It's not A, it is not D. It's either B or C. So what do we do in this case? This is an analysis, purely analysis problem, but it has some physical meaning. The deflection, you take a step back and say, deflection is bad. Deflection is not good. I wish we can design a structure that has zero deflection. That's an ideal world. Maybe if you're designing a nuclear power plant, maybe, yes, you shoot for close, extremely close to zero, but we cannot get rid of deflection. So deflection is bad. I cannot go ahead and say my deflection is 2.1 and then I'm going to tell you it is less than 2.1. That's not conservative. That might create problem. You know, glass might be under this beam and it will crack and so on. So even though I calculated 2.1, I have to go and say the deflection is 2.25. You go a little higher because it is conservative. It has some physical meaning. Now let's go to this problem. Same problem. Now you are asked, this is the cross section of this beam. The beam has width of B and height H, and you are asked to design the beam. So let's say that we design it. We found that 9 by 3.3. That's the required. 9 is H, 9 inches, and B is 3.3. So now we go to the choices. It is not A, it is not C. The answer is either B or D. See, it's either 4" or 3". So what do? 3" is closer to 3.3. But if I select D, that's the wrong answer, because that's not safe, that's not conservative. You found that you need a minimum of 3.3, so you have to go and increase it higher to 4. So the answer is B. And the last problem is this is a concrete. This is concrete retaining wall. This is soil pressuring. This active soil pressure pressuring the wall, and the wall will tend to rotate around this point. To rotate or overturn. This whole wall will try to flip, or will tend to rotate around this point. So the question is the safety factor against overturning around this point. So you calculate, we're not covering this, we do this in soils and foundations class. So you calculate the safety factor, it's 3.6, okay? So that's 3.6. So what do I select? It is not this, it's either A or B. So should I select A or B? You cannot select B in this case, because you cannot calculate a safety factor of 3.6 and you go report to the client or to the other engineer or to whom you are reporting to. I have a higher safety factor than what I calculate. So in this case, you go conservative and you say, I calculate 3.6. I'm going to tell you that I have, or you have on this structure, 3.4. That is safe, it's a good design, and that's conservative. And that's what they want you to make those type of judgment by when they ask you find the most nearly. This is the PE sample passing rate. You can take a look at it just for your own information. This is the exam schedule from ncs.org website. What kind of material you are allowed to bring with you to the exam? You can bring, this is from ncs.org, you can bring material that's your hand written thing or some things copied from certain text, but they have to be bound so you can read this. They don't want any loose papers, and they allow for sticky notes and flags. They are allowed. This is ncs.org requirement. It says certain books that's prepared for the PE exam, like the Lindbergh book, Potter books. You can bring the book with you, but not the solution manual, only the book. This is I am in Illinois, in Chicago, so this is the Illinois Department of Financial and Professional Regulations requirement. They are a little more strict, so they don't want you just to copy material, different textbooks and bond them. They are a little more strict, so you have to contact the board and see what they in your state and see what they allow and what they don't allow. PE design standard. There are codes for different disciplines. For example, the civil, all of those they have codes, and also the same thing for the rest of the fields. So let's go through the civil. For the civil, if you are taking the afternoon in the construction, those are the codes you need to bring with you to the exam in the afternoon. They will certainly ask you questions from them, so you have to bring them with you. If you are taking the PE Civil and Geotechnical, there are no codes, there are no design standard, but here are the topics that they will ask you from. Go to this website, ncs.org website, to get a complete list. This is just partial list, so you know they are there. If you are taking the afternoon Civil and Structural, here are the codes. If you are taking afternoon Civil in Transportation, here are the list of codes you need to take with you. And finally, if you are taking the afternoon in Water Resources and Environmental, there are no codes, but here are the list of topics, partial list of topics. Books, I recommend you buy ncs.org books, because they are the agency who put the exam. Here is another agency that they have good books. ncs.org website gives you a list of books. In the case of civil, I recommend you buy them and you solve them and you study them, because they resemble very well what's going to be in the exam. This agency has this reference manual, which is a good one. 6 minutes. The reason why 6 minutes, because each question in the PE has 6 minutes, 40 questions, 4 hours, that's 6 minutes per question. So those are some good sample exam. Calculator, make sure that the calculator you use in the exam is on this list, otherwise they will not allow it. So go to ncs.org website to make sure that this list is up to date. So here are some notes on how do you prepare for the exam. First, study topics that is directly related to the exam. If the probability of the topic is not going to, the probability is too low that a question or a topic will appear in the exam, only if you have time, go ahead and study it and spend a couple of days reading it. If not, just go to the topics that has higher probability of appearing in the exam. Solve more examples than just studying theory. I have seen some engineers where they were students, they just study theory. Go to examples and more than theory. And go to the theory only if you are not up to date in that topic and you need to refresh your memory. Selected samples that you're going to study should be as close as possible. So how do you know that? Well, look at the sample exams. And if you're taking a refresher course, I know the refresher course I teach at IIT, we try to follow this logic, that you cover all the topics, but not in depth. It's your responsibility to go ahead and go in depth on each one of those topics. And I think it works. This is a very good method. PE exam fact, NCS suggests passing score. It's not curve, it's a passing score. All 50 states in the US adopt this recommendation. There are 40 points in the morning, 40 points in the afternoon. Exam questions might have unnecessary or additional data. Well, if you are prepared well, you will know that those are unnecessary additional data they are giving you just to test your knowledge. And then common mistakes are repeated in the answers. How do we guard against that? Well, you need to double check your answer. I recommend highly double check. Don't just punch in the calculator and you're happy that you get the answer and you mark it and go. Always double check. If you don't pass, NCS will give you a diagnostic report, and here's a sample where this gentleman is a chemical engineer. Here are the topics. If you add all of those, this becomes 80. That's 80 questions. The number he have solved correctly, you can add those, but I believe it's less than 50. That's not enough for him to pass. So in this field, for example, this is the average. He scored way below the average. In this one, this is the average. He scored higher than the average. But you can see most of what he answered is below the average. So it'll give you a diagnostic report so you know which areas you are weak in, so next time you have better chance. Exam tips. Take a mock exam. If there is an agency in your area that have a mock exam, I highly recommend take it. Pay for it and take it. If not, you can do your own mock exam. The day before the exam, solve complete sample exam. That could be your mock exam. 20% of the questions in the exam are repeated. That means the sample exam questions you have in your hand, 20% of the questions will be repeated. So that's it. Why not study them and focus on them? Concentrate on subject you know well. I think I mentioned that. Subject you don't know well, at least you need to be prepared to solve the easy questions from those subjects that you don't know or you're not fully familiar. I highly recommend this. I have done it, and I really recommend my student take a week off around the week. Take off around the week before the exam and go just to the library and study. Don't do anything else. In the exam, use a stopwatch because that will help you monitor your time. Tag the books in the PE months before the exam start. Tagging the books. Why is that? Because it will help you save time in the exam. If you have to guess and you don't know the topic, well, use your judgment. Use your judgment, process of elimination. Eliminate one or two answers, and then rather than just blindly marking it as C or D or whatever. Do not spend inordinate time in any single question. If there is one question and you feel that you are spending way too much time on it, you're spending 8 minutes, 9 minutes, 10 minutes, and you after the 10 minutes look like you have no idea what you are doing, and even if you get the answer, you are not sure of this answer. This type of question is not made for you. You might be better off just answer it, guess on it, your best judgment, and go to the next one. Solve first the easy and most familiar questions to you. Don't just solve them 1, 2, 3, 4. No. Start with the one that you know and you have high certainty that you will get the answer correctly. And then finally, strategize. To me, it's better if someone, after the exam, I ask him and say, I solved at least 70% of the questions and I am almost 95% sure they are correct. It's better than someone says, oh, I answered all of the questions, but how many of them you are sure you answered correctly? The answer is, I don't know, or 50 or 60. That's not good. So that goes to this one. Solve the easy questions, solve the questions you really know, and rather than just guessing on the other ones. And the final topic is prepare some kind of indexes for you. So this one is called exam or questions oriented index. So if you're a civil engineer, you're taking it in the structural field, you know they will ask you questions from concrete structures. So you could speculate on what type of questions they will ask me. They will ask me to design beam, columns, and so on. So you go write this with your hand on any one of those book flaps or anything. You say, if they ask me a beam, they ask me to find the reinforcement, that's A sub S. On this beam, there's a very good example on so-and-so book and so-and-so page. And so on for the rest of all the topics. So in the exam, if you have a beam that they ask you find the reinforcement, you open your index, which is exam questions oriented index. You open it, you go to this page, and you have the solution right there, the formulas and everything. So it saves you time. Now here's a sample exam question oriented index. So for example, if you're structural, here's a multi-story building and they ask you to design certain bar, you go to so and so and the check certain thing. This is just some handwriting. Or if you can write this, if they ask me to design this tube steel, or to check the tube steel, page this, number this, and then you go to this topic. So this is exam question oriented index sample. Another type of index is index for an entire book. You go to this book, for example, ACI 318 code. At the inner flap, you just say, if they ask me for delta, which is find the deflection, I go to this page. If they ask me to calculate the width of anything, the width of T section, there are good examples on those pages. So this is index of an entire book, and you are putting on the flap only the topics that might appear in the PE exam. And finally, index for each chapter in a book. So you go to this chapter. This one happened to be notes on ACI 318. You go to this chapter 7 on the page. You say, if they ask me to design, this is a cross section of a beam that has reinforcement, and this one question mark, meaning find the width, find the depth, find the reinforcement. So if they ask me this, here's a good example. If they ask me to find the reinforcement in a T section, here's a good example. So that's for the chapter, but it helps you save time. So that's it. This is my my presentation. I hope you find it helpful to help you pass and prepare the PE exam. My emails are both emails are on the front or the first page of this presentation, so you can email me if you have questions, and I hope you found this presentation to be helpful to you, and good luck.